So this little video is on using the final speed or the final velocity equation, v squared equal to u squared plus 2as, where the v stands for the final speed or the final velocity, u is the initial speed, a is the acceleration, and s is what we call the displacement. And that 2 is just 2, okay? So the first thing I want to show you is how to rearrange the formula using algebra, okay? So let's say I want to solve this sum or this equation for v equals. Well, I start off with my equation that I'm given, v squared equal to u squared plus 2as, and I know that I have to, in order to find v is given here as a square root, but if I get the square root of that v squared, v is given as a square, so if I get the square root of that, then that will undo the square root, if you like. It's the opposite mathematical operation, just like multiplication and division are opposites to one another. Squares and square roots are opposite to one another. So what I do is I get the square root of that side, but if I'm going to get the square root of that side, then I have to get the square root of the other side as well, just to maintain balance. And that's basically it done. The square disappears with the square root, or it cancels with the square root, and that gives me the final velocity v equal to the square root of u squared, or the initial speed, or the initial velocity, plus twice the acceleration times the distance, and of course that is the distance through which it's accelerating. Okay, the next one I'm going to do, I will do it looking for the acceleration. Okay, so I'll just change this around a small bit. So again, we start from the same place. You start from the final velocity equation, and I'm going to, this time, I'm going to make a, or the acceleration, my subject. In other words, that's the one that I'm going to try. Sorry, no, a is not the subject in this one, my apologies. It's u, okay? So the initial velocity is going to be the subject. Now, normally I would put a ring around that, but I forgot to do it when I was doing this one. My apologies, okay? So what I would do is I look around my subject, which is u, and I say to myself, well, what is the 2as doing to the u? So you realize, well, it's adding to the u, so therefore the opposite of adding is subtraction. So you subtract a 2as on the right-hand side, and if I subtract it on the right-hand side, then I must also subtract it on the left-hand side to try to maintain that balance, okay? So you subtract them, that 2as on the right cancels out the one that was already in the formula, and that leaves you with the initial velocity squared equals the final velocity squared minus 2as. Now, the last little step that I want to do is, because that's in a square, so just like in the previous example where I had a square with the final velocity, I took the square root. So I'm going to do the exact same thing again. I take the square root of the initial velocity squared. That will give, because I take the square root of that, I must also take the square root of the other side. That will maintain the balance, and that gives me the initial velocity equal to the final velocity or speed minus twice the acceleration times the displacement. Okay, hopefully that makes sense. So the next one I'm going to do, again, starting from the same place. Now I'm going to make acceleration the subject, and now I've done it correctly. When you make something the subject in an equation, my advice is put a little ring around it. Excuse me. Put a little ring around it just to remind yourself that this is what you're aiming for. So you look around and you see, well, what's the u doing to the 2as? Because the 2as is all stuck together at the moment. We'll deal with that last. And you realize that, well, the u is actually adding to the 2as because it's a positive u squared. So the opposite of addition is subtraction. So if I subtract it on the right, then I must also subtract it on the left. The u squareds on the right will cancel out, and that will give me the final velocity squared minus the initial velocity squared equal to twice the acceleration times the displacement. But I'm not done. That A is now still stuck in between the 2 and the S. So you have to ask yourself again, what is the 2 doing to it and what is the S doing to it? Well, they're both multiplying the A. They're both multiplying the acceleration. The opposite of the acceleration, the opposite of multiplication is division. So I will divide on the right hand side by 2s. And of course, you guessed it, if I divide it on the right by 2s, I must also divide it on the left by 2s in order to maintain that balance. So the next thing is that the 2 will cancel with the 2 on the right, the s will cancel with the s on the right, and that leaves me with the acceleration equal to and the final velocity squared minus the initial velocity squared divided by twice the distance covered while accelerating. Okay, hopefully that makes sense. You gotta practice these ones, guys. You gotta practice them until you get them. So the last one that I'm going to do is looking for the S. So I'm going to make the S my subject. This time again I did it the right way, so I put a little circle around the S to remind myself that that's the subject, nothing else. Focus on that, look around it, see what everything else is doing to that S. Again, the 2 and the A are stuck to the S, so for now we'll leave them where they are and we'll deal with the U squared first. U squared, just like in the last example, is adding to it, so I should subtract a u squared on the right. Because I subtracted on the right, I must also subtract it on the left, and that gives me the final velocity squared minus the initial velocity squared equal to twice the acceleration times the displacement. Again, that displacement S is my subject. So now I have a little look around and I say, well, what's the 2 doing to it and what's the A doing to it? They're both multiplying the S, okay? Again, the opposite of multiplication is division. So I divide on the right by A and 2. If I divide on the right, then I must also divide on the left by the same amount. The 2 cancels with 2, the A cancels with the A, just like in the last example. That gives me the final formula for the displacement is the final velocity squared minus the initial velocity squared divided by twice the acceleration. Hopefully that makes sense. Please practice this. Practice rearranging these formulas to death, okay? Practice them until you know them inside out.